Hi guys, my name is Abhijit. This is my first video on YouTube channel. Today's topic is about small concept, but it's really important, which we normally use in physics, solid mechanics, and theory of machines. It's about when body can be assumed as a particle. Normally when we say particle, we tend to imagine a small dot like this. And when we say body, we imagine something like arbitrary shape. But do you know the bus moving along the straight line can also be assumed as a particle, something like this? And a tiny rotating portable fan cannot be assumed as a particle. So the concept is not about the size of an object, which we normally tend to imagine. So the real thing is like a body can be assumed as a particle if each and every point of that body has the same velocity. Okay, and by velocity I mean speed and directions are same, right? So let's imagine driver here is driving at say 60 kilometer per hour, right? And you're sitting here and I'm sitting right behind you. So if this driver is driving at 60 kilometer per hour, you and me both are traveling with 60 kilometer per hour in the same direction. Okay, so this bus as a whole body can be assumed as a particle. Now someone will say like the wheels, they are rotating, right? So the velocity won't be same. But if we consider the center of gravity of this wheel, that is also moving at 60 kilometer per hour in the same direction. So this bus can be assumed as a particle. But if we come to say a portable fan, let's say it's rotating with say angular velocity of omega in anti-clockwise direction, right? If we consider the point at say midpoint of this blade, it has velocity v, so obviously towards the end the velocity will be 2v, right, since the omega is constant. So velocity here, it's not same everywhere, so this cannot be assumed as a particle. Okay, now it cannot be assumed as a particle. This can be assumed as a particle. So just remember one thing: if you're calling body as a particle, make sure you should check all the points on that body, whether it has same velocity or not. If it has same velocity, you can call it as a particle. It's really simple. Now let's consider another case. It's an interesting case. Let's consider this bus is moving along the car road, right? You and me are moving along the car road with a center of rotation along with some radius of curvature is r, and now you're sitting on the inner side of the bus and I'm on the outer side of the bus. Let's call this w as the width of the bus, right? So at this instant this bus cannot be assumed as a particle because you're sitting on the inner side of it. Obviously you're going to have less velocity compared to me. So ideally this bus moving along the curved surface cannot be assumed as a particle, since you sitting on the inner side has different velocity than me sitting on the outer side. But in some cases it can be assumed as a particle because, as you know, v is equal to r omega, dv is equal to dr omega. Of course dr is equal to this width of this bus. Now the change in velocity between you and me is really negligible compared to the radius of rotation, right? You getting this? So in this case it can be assumed as a particle since this width is really small compared to radius of rotation. So I hope you like this video. If you got any doubts, you can write below in my comment section. Any suggestions, always welcome in comment section, and please don't forget to like and subscribe my channel. Thank you.